we studying 10G, which is called the remainder and factor theorem. So have a think about what we have learned before. It's all connected together after like last lesson. So last lesson we learned basically two methods for polynomial divisions. We have long division method. We can see what's the quotient and what is the remainder. And then the second method I use is a box method. When you're trying to divide by a linear and it's a x plus a or x minus a linear, I can use this box to achieve the same result as long division. So basically what we learned last week for two lessons is about polynomial divisions. So today we will keep going with that. So have a revision on what is a remainder. Remainder is when you do a long division, the last number there is a remainder. Okay, the last number has been left over is called the remainder. Or say in the box method, the last number like under the constant, that is the remainder. So that is called the remainder, which is something has been left over. So today we want to think about the remainder theorem and factor theorem. So what is a remainder theorem? So divide px by this, okay, divide px by this, and then I want to evaluate p negative half as well. We want to divide p negative half as well. So let's do this quickly. Let's do this quickly. I'll try left hand side by long division and right hand side by the table method. So because this one is not really suitable for box method because it's not x plus a or x minus a, it's 2x plus 1. So which is not that good to use box method. So I will try to use long division for this one. But I give you a warning, this one is very hard to calculate. The number is not very nice. So we need to be quite careful about this. Okay, before what we do is all divide by x plus a or x minus a. So we haven't really dealt with 2x plus 1. So let's have a think. The first divide by the first, what do you have? 3x cubed divided by 2x, what do you have? 3 over 2x squared. After we have that, we use that to times with 2x plus 1. So I have 3x cubed plus 3 over 2x squared. Okay, what's the subtraction between those two terms? 2x subtract 3 over 2x squared. 2x squared subtracts 3 over 2x squared. What do you have? Half? Half x squared. After I have the difference, I'll move next term down, which is minus x. Okay, then we will use half x squared divided by 2x. What do you have? Quarter x? Good. So quarter x times 2x. So half x squared. A quarter x times 1 is a quarter x again. Okay, we almost there. What's the difference between those two terms? Anyone? What's the difference? Sorry? Minus 5 over 4. Everyone agree? Subtract 1 and subtract a quarter. So it's subtract 5 over 4x. And move the last term down, which is the minus 2. Okay, and what we will do is use this term to divide by 2x. What do you have? No. Okay, what's 5 over 4x divided by 2x? Minus 5 over 8. Good. And I will times it is minus 5 over 4x minus 5 over 8. Okay, what's that? What's the difference here? $11 over 8? 11? So minus 2 is minus 16 on 8, and minus negative 5 on 8 is actually a plus. So you have minus 11 over 8. It's minus 11 over 8. If you can't do it, you can't think about it, just write the equation beside and then try to calculate. So make sure like each step is correct, because if you have a mistake in the middle, it's definitely wrong for the rest. Okay, it's definitely wrong for the rest. Okay, so the remainder is minus 11 over 8, right? The remainder is minus 11 over 8. That's A asked us to do. Okay, that's 1 asked us to do. Let's have a look at 2. 2 is asking us evaluate negative a half. Why asking us to evaluate negative a half? Let's write this expression down first. Let's write px. Okay, let's write px. Px equals to 2x plus 1. And 3 over 2x squared plus a quarter x minus 5 over 8. And then minus 11 over 8. Okay, we call this, normally we'll call this qx, and we call the remainder r. Okay, we said what you're trying to divide is a qx, and then the remainder is called a r. That's just the name of it. You can say that's OX, RX, whatever you like, but like normally we express it in a way that is QX and then plus the remainder. All right. Let's have a look at P negative a half, what that equals to. That's 3 times negative a half cubed plus 2 times negative a half squared minus negative a half minus 2. Okay, just put negative half into the px. So px is that. I want to put negative half into that. So substitute negative a half instead of x. Substitute negative half into x. So what we have is negative 3 on 8 plus, okay, what's that? That's a half, a quarter times 2, which is a half, plus a half minus 2. Let's say minus 2 is 8 on 16. That's a plus 1. So that's plus 8 over 8 minus 16 over 8 plus 5, that's minus 11 over 8. What do you find? Question?
How do you get from the top right?
Which one, sorry?
The top one.
This one? This one? Oh no, that's only part B. That's another question. B is asking us to solve for P negative a half.
Oh.
B is asking us to substitute. That's telling you you need to substitute that point. Okay?
Except when you substitute, why do you like
Oh.
get rid of Oh, because you use the equation on the top.
Yeah, use the equation on the top. I'm not using the transformed equation. I'm using the original equation. That's what I'll explain later. It's not. That's why we need to compare. What do you see? Shh. What do you see? Compare A and B. What's something you noticed and something we may think about? It's not remain the same. We get the remainder, and the second one got the remainder as well. Like using a way. Well, I'm not sure if it's coincidence or like we will really get the remainder. Let's have a think about the value what we substitute. What we substitute is negative a half. Okay, what the negative half will do? The negative a half can make this expression become 0. Can you see that? Can you see the negative half? What the negative half will do? The negative half can make the remainder, not the remainder, what you're trying to divide become 0, right? And then let's think about this thing. Let's know to do the long division first. Let's just say we have px divided by 2x plus 1. What we can write is px must be equals to 2x plus 1 times qx, like times something, whatever, on the long division. Like, I don't know what is it. Let's say, suppose like we just write qx there. And then I also need to plus the remainder r, right? That's the way how we write it. So it's like we have px here, and then we divide by 2x plus 1. We have something on top, and we do whatever we do here, and we have a remainder r. And then we rewrite the equation. We say px equals to 2x plus 1 times r and times qx times plus r. And then what we substitute is a number can make what you're trying to divide become 0. So basically it's making that become 0. So we put p negative a half in. Let's see what will happen. I put negative a half in, that number becomes 0. So that's a 0 times qx and plus the remainder r. 0 times qx, just nothing. What has been left is only the remainder r. Okay, so which in this way we prove that when we substitute negative a half, the number we get is definitely the remainder. Okay, it's definitely the remainder. And what I'm showing here is why negative a half, I substitute that point in, I could get a remainder. It's because it doesn't matter what is the qx. If you make what you're trying to divide become 0, that whole term just becomes 0. And then what has been left is the remainder, the last remainder. That's why you will substitute a value that can make what you're trying to divide be 0. And then that number you get is the remainder, regardless what is the qx. I don't care about that. I just want to know the remainder, for example. All right? Yes, that's why I sub negative a half. I should get the same number like above. Let's just do another example here. Okay, divide px by x plus 2. Divide px by x plus 2. So we can write this way first. I'm not following the question now. What I'll write is px equals to x plus 2, qx plus r. I know I can definitely write that in this form. I know in the end I can definitely write that in the form. So what I can do is like x cubed plus x squared minus 14x minus 24 divided by x plus 2. Well, I have some expression qx above, and then subtract until the end I should have an r. And that inside thing must equals to x plus 2 times qx and then plus the last number r. So now what I'm trying to substitute is a number can make this become 0, which is negative 2. I will sub p negative 2 into that. I will get the remainder r. So what is p negative 2? P negative 2 equals to negative 2 cubed plus negative 2 squared minus 14 times negative 2 minus 24. That's a minus 8 plus 4 plus 28 minus 24. That's a minus 4, that's a plus 4, and we get a 0. Okay, so just basic calculations, I sub negative 2 in. I've proved it again. Why I substitute negative 2, I will get remainder. Okay, if I substitute a number that can make the number you divide become 0, and then you will have the remainder. But what we have is a remainder 0. Okay, there's no remainder. Okay, there's no remainder here. Yes? If you sub negative 2 into that term becomes 0. And the QX gone.
Oh, yeah.
That's QX. Why QX disappeared. So it's basically 0 times QX plus R. And it's just equals to R. Okay, I'll double check it by using the table. Just get a little bit of revision on that. Okay, the coefficient is 1, 1, negative 14, and negative 24. And the number I want to substitute is negative 2. Okay, the number I want to substitute is negative 2. And then first number directly go down. Negative 2 times 1 is negative 2, plus 1 is negative 1. Negative 2 times negative 1 is 2. 2 minus 14 is minus 12. Minus 2 times minus 12 is 24. 24 plus negative 24 is 0. I have a 0 remainder. I have proved it by this table method again. I should have a remainder 0. And then both methods has confirmed that we don't really have a remainder. We don't have a remainder. So Px can be written in the way that's x plus 2, x squared minus x and minus 12. By the table method, that's what we can write. And we plus a 0 remainder, so there's no remainder. You don't need to write the plus 0. I'm just writing there to show you that there's a 0 here. Any questions? Any question for that? No. Okay, if not, let's have a look at the definition below here. The remainder theorem. This is called the remainder theorem and the factor theorem. That's what we learned this lesson. So, remainder theorem says when Px is divided by Ax plus B, the remainder will be P bracket negative B over A. So, I will substitute a point into P, but what we're trying to substitute is you make Ax plus B equals to 0. Remember that's because Px will equals to Ax plus B times Qx plus remainder. So you will substitute a value, can make Ax plus B become 0. So x will be minus B over A. You don't need to remember this rule. What you need to do, like when you do the question, is you make it equals to 0. You solve for x, and then you substitute that in. You don't really need to remember minus B over A. That's quite hard. So do not try to memorize a lot of equations, trying to understand it and then apply to it. So what we're trying to do is make the thing become 0, because then Qx will disappear. What has been left is only remainder R. So we solve x plus b equals to 0, substitute into the Px, and find the remainder. So P negative B over A must be equals to 0 times Qx plus R, and that is R. Okay, that is R. That's why P minus B over A equals to remainder. And the factor theorem is very similar to remainder theorem. What it says is, if x plus b is a factor of that, then p minus b over a is 0. Okay, have a think about that. There's no remainder. Then I'm trying to divide that, and I substitute that number in. I should have 0 because that's 0 remainder. When there's a no remainder, ax plus b is called the factor. Ax plus b is called the factor. So this is very important. We have that one is like when I substitute and I see a 0, and then I say, oh, the remainder for that one is a 0. The remainder is a 0, then which means ax plus b is a factor. Or if you have ax plus b, you know that's a factor already. You know that when you substitute minus b over a must be 0. Okay, it's vice versa. So you know that's a factor. Then you know definitely you substitute the value minus b over a in, that's a 0. Or if you substitute the value in, you already find that's a 0. Which means x minus that is a factor. So I want to actually change this one a little bit for you. I don't want to use that one because it's quite confusing. That's the book definition. So what I want to change is, if b substitute a point, well, let's substitute point c. Let's say we substitute point c into p, that equals to 0. C can be anything. C can be any real number. Okay, C can be any real number. If we find a value can make the equation become 0, then the conclusion we can make is x minus c is a factor of px. Okay, I don't want to use the minus b over ac and ax plus b. That's very annoying. I just want to say, if you know a value, you put that value into the equation, can make the equation become 0, then x minus that value must be a factor. Must be a factor. If you substitute c in, then which means the original equation you have is x minus c. And then you can do like factor theorem, then that is a factor. Because remainder is 0, then that means it must be a factor. Alright. Let's have a look at some questions. It can make understanding better. So this one, it says, find the remainder when px is divided by x minus 2. Okay, I haven't asked you to find anything else. I just want to know the remainder when you're trying to divide by x minus 2. So x minus 2 equals to 0. X will be 2. So I will substitute P2. Okay, I want to know the remainder for Px divided by x minus 2. What I need to substitute is P2. Is 2 to the power of 3 minus 3 times 2 to the power of 2 plus 2 times 2 plus 6. That's 8, 12, 4, 6. And then 11, 6. 8 minus 12 is minus 4. Minus 4 plus 4 is a 0. And then plus 6, that's 6. It's quite easy, right? It's better than long division and find the remainder. But I will still recommend you to use the box method. Well, if it's ask you remainder theorem, okay, I make it clear. If ask you remainder theorem, this is the remainder theorem. You must use that one. Okay, nothing else can be remainder theorem. I can do long division to find the remainder. I can use box method to find the remainder. But remainder theorem is only this one. You substitute minus b over a. That's the remainder theorem. It's nothing else. But if it hasn't asked you to use the remainder theorem, what I can do is the box. You know why I say the box method is the best one? Because you not only can get the remainder, you also can get the QX. You can get both things at the same time. And the calculation is actually easier than substitute values in. Okay, it's purely times and add, times and add. So what we will have is 1, -3, 2, and 6. What you're trying to sub is 2. I'll have 1 down first. 2 times 1 is 2. 2 plus -3 is -1. 2 times -1 is -2. -2 plus 2 is a 0. 0 times 2 is a 0. 0 plus 6 is a 6. Can you see that takes you about like 10 seconds about doing that? And you have both the remainder and the QX. So Px can be written in the way x minus 2, x squared minus x, plus 0, and then plus 6. You have a plus 0 inside, but you don't need to write that. Okay, you have both the QX and the R. So that's why I said the box method is the best one. You can do everything by easy calculations and you get everything. Okay, the next one. Px equals to x cubed minus 4x squared plus x plus 6 is divided by x plus 1. So using remainder theorem, I'll write this down here. Using remainder theorem, I need to find remainder equals to p negative 1 because I need to make that equals to 0 and I will sub negative 1. I know in the test, a lot of you still will give me p1 instead of p negative 1. Remember, it must be what you're trying to divide equals to 0 and solve for that and then you substitute. It's not directly substitute like the b values. So what is p1? P1 is p negative 1 is negative 1 cubed. Okay, is that? Negative 1 minus 4 minus 1 plus 6. That equals to 0. Okay, 0 is something you need to be aware of because 0 means no remainder here. Okay, no remainder here. So because the remainder equals to 0, so we will say x plus 1 is a factor of Px. Okay, because that's a factor, so remainder equals to 0. Because remainder equals to 0, so x plus 1 is a factor of Px. Very important, okay? We use that next lesson, or maybe just later. We use that a lot. We just keep using that to factorize the polynomial, the cubic or even quartic. And then we try to graph or solve for it. So 2 more things we need to do is graphing and solving for polynomial functions. Okay. Let's have a look at example 3. Example 3 can be a very tough calculation. Function fx equals to 2x cubed plus ax squared minus bx plus 3. Okay, have a look at this expression here. A and b are called the constant. and x is the variable. Because in the bracket is x, it's not a and b. So x is the variable, but a and b are constant. You just you don't know that constant, but it is a constant there. Has a factor. Okay, this function has a factor x minus 3. So is a factor. And then when fx divided by x minus 2, we have remainder 15. You divide by that, remainder equals to 15. What you can tell from those two information? It asks you to find the value a and b and hence find the other two factors. But I don't care the question yet. What you can purely tell from x minus 3 is a factor. Remainder 0? Yes, remainder 0. And what else? Yes, f of 3 is the remainder. And because there's no remainder, we will say f3 will be 0. Because it's a factor, therefore remainder will be 0. How do I find the remainder when px trying to divide by x minus 3? We will say p3 equals to 0. Okay, p3 is the remainder, and then that's 0. Question? No? What you can tell for x minus 2 got a remainder 15? F of 2 equals to 15. F2 is the remainder, and the remainder is telling you the remainder is 15, so F2 is 15. Okay, F2 is 15. So what we can do after we know those two things, I will substitute. What's F3? F3 is 2 times 3 cubed plus a times 3 squared minus b times 3 and plus 3. That equals to 0. What is F2? F2 is 2 times 2 to the power of 3 plus a times 2 to the power of 2 minus b times 2 plus 3 equals to 15. I'm going to calculate this. 3 times 3 is 9, 9 times 3 is 27, 27 times 2 is 54. Plus 9a minus 3b plus 3 equals to 0. And we'll say that's a 57. I can plus that to here. They times plus together, that's a 57. Everything can be divisible by 3. So 3a minus b plus, divide by 3. 19. And this side, 2 times 2, 4. 4 times 4 is 16. Plus 4a minus 2b plus 3 equals to 15. Okay, that's 4a minus 2b. Okay, 15 move to that side, you have a 1. And then plus that 3, you have a 4. And equals to 0. Divide by 2, 2a minus b plus 2 equals to 0. Okay, we have those two equations. How we can solve for it? Yeah, how you will solve for it? Sorry? Make them equals to each other. How can I have both A and B in both equations. Well, if that helps, if I can write that, I can do that. I'm solving for those two equations. Oh, I don't have enough space. That's fine, I'll just clear this part. No? Okay, I'm holding it. That's fine. Okay, so I'm solving for that. What's the best method we solve for that? Elimination. How we can eliminate that? Subtract or add? Subtract. So use the top one to subtract the bottom one. 3a minus 2a, we have a. Minus b, subtract negative b, we have 0. 19 subtract 2, we have 17. And 0 subtract 0, we have 0. So a equals to negative 17. What b equals to? B equals to 2a plus 2. So that is 2 times a plus 1. That's 2 times negative 16. That's minus 32. That's minus 32. Okay, I have checked it and that's correct. So A is this, B is this. And let's rewrite that expression. 2x, okay, 2 negative 17, positive 32, well, I'll just change it to this place. Okay, what's A? A is negative 17, right? Negative or positive? Negative, and B is negative 32. Okay, so what fx is? Fx is 2x cubed minus 17x squared. Okay, minus b, so minus negative 32 is a plus 32x and plus 3. I've solved that on the previous page, and that's a new page. So what we have is fx is actually that. Okay, I know x minus 3 is a factor. Okay, I know x plus 3 is a factor. So fx must be right in the way that is x minus 3 times qx and plus a 0, right? That's the meaning of a factor. Is x minus 3 times qx. How we can find qx? Table. Yeah, we can use tables, or we can use long division, or we can using the method like the recognition method. I'll show you I'm not going to show you long division. Long division just use px to divide by that, and whatever you get is qx. So if we use table, it's quicker. If we use table, it's a bit quicker. So table is 2 minus 17, 32 and 3. And then I will sub 3 in. The first one is a 2. 6. 6 minus 17 is minus 11. Minus 33 plus that is minus 1. 3 times minus 1 minus 3 plus 3 is a 0. So my qx is actually 2x squared minus 11x minus 1. Right, this table is using by that. And I have the table and I can find what is my qx. Okay, by knowing the QX, it's in the factorized form, right? Something times something, no plus. But that's a quadratic. That's a quadratic at the back. Can we further factorize it or not? Yes? How do you test whether quadratic can be further factorized or not? How we can tell? We learned at which chapter? Chapter 6? How do we test whether quadratic can be further factorized or not? Discriminant needs to be greater or equals to 0. Okay? Discriminant needs to be greater or equals to 0. That's how whether it can be further factorized or not. So let's times that. Discriminant for that is minus 11 squared minus 4ac. B squared minus 4ac, right? B squared minus 4ac, that's the discriminant. Well, that's 1 to 1 plus 8. Well, it doesn't matter what is it, that's definitely greater than 0. If it's greater than 0, it definitely can be further factorized. It definitely can be further factorized. You can change another page, I think, it's too little space. Yeah. You can do it in the last page. Who can factorize that for me? If you can't, just please stop talking. If you can, please come up to do it. Okay, so what's the method we can do factorize? What's the method? Like what method we can use? There's multiple methods. Completing square? Okay, this one looks quite like a completing square because there seems no better ways to do it. Yeah, cross multiplication can be one way as well, but it seems like a 2 and a 1 can't make 11 for you. So the cross multiplication can't work. So what you can do is completing square. And I will tell you that's a really terrible completing square and the number was really unfriendly. Okay, so you can have a try to complete square by yourself. Seems like you don't want to, but like you need to. Okay, trying to complete square for this one and then further factorize that. That's the last question, okay? That's the last one. Yes?
When you complete the square, does the plus or minus go first?
Plus go first. So give you a hint. It can't do for 2a squared, 2x squared. I need to take the 2 out. Okay, that's your first step.
It's actually circling your minus 4.
That's your first step. Okay, you want to keep factorize that. And the only method we can try is completing square. And for completing square, you need to make a single x squared then to complete it. You can't have multiple x squares there. So we take a 2 outside as a common factor. And then my middle term b is 11 over 2. So what we will do is plus half of that square, subtract half of that squared. And don't forget you have a 1 on 2 as well. 11 over 2, half of it is 11 over 4. So half of the b squared. And then subtract half of the b squared. That's how you complete the square, right? X squared plus bx plus c plus half of the b squared, subtract half of the b squared. Okay? And then I can complete square for the first 3. And I will calculate the last 2. So remember, as I said, there's always a bracket here. And you're adding a new bracket about those 3 terms. So what you have is, well, you take the x, you take the sign, and you take the number in the bracket. So it's x minus 11 over 4 squared. Okay, what we have here? Minus 121 over 8. Not 8, 16. Minus 8 on 16. So that is still keep in the bracket. That's x minus that squared minus square root 129 over 4 squared. Okay, 1 minus 8 is 129 minus 129, so square root 129 over 4 whole thing squared. Because I want to use a squared minus b squared form to factorize it. A squared minus b squared form to factorize it. So what we have here is x minus 11 over 4 plus root 129 on 4, x minus 11 over 4 minus root 129 over 4. That's the other 2 factor. That's the other 2 factor. I have a linear, a quadratic, and the quadratic can be further factorized into 2 linears, and we have 3 linear factors. Okay, 3 linear factors. Yes.
The x minus 11 is that the factor?
Like this is one factor. This is another factor.
What do you do with the 2?
It doesn't matter. 2 is a constant. You can combine it inside the bracket. You can times this with any one bracket.
Alright, so you don't need the time to get the...
Or you need to take the whole thing into the original equation. Like it's 2, that linear factor, and x plus 3. No, only 1. If you want to put it inside, you only put it once. Yeah, if you want. No, you not have to put. You don't have to put it inside. What you can do is fx is 2x minus 3, x minus 11 over 4 plus root 129 over 4, x minus 11 over 4 minus root 129 over 4. Like this. You just take the whole thing. You can combine the 2 with any bracket. You can go inside that one, 2x minus 6.
Wait, so that's not the factor, that's the...
Well, it's a constant, it's not a factor. Like the factors involve x. It's more like a coefficient. It's more like a number. Well, it's not a factor, it's not having 4 factors. The factor is the linear.
Okay, so the question said like find
Everyone, I'm not finished talking. What's that?
So it said find the other 2 factors. So what are the other 2 factors?
Here. Those 2. Those 2. You don't need to worry about the 2. If you really worry about it, just combine it with any function. Well, you not only have a unique solution. That 2 can be put inside. And then this one is still the same.
So if you divide it, the equation to add those to get a remainder zero.
Yeah. You always get the remainder 0.
Okay, so if it was 2x,
Sorry?
so if it was a 2x plus 1, you would get a remainder 0.
Yeah. Yeah, the remainder is always 0. Doesn't matter. Because you enlarge everything by 2. You enlarge everything by 2.